So road transportation globally accounts for about a fifth of all the CO2 emissions worldwide. And how much do you think is the drag from the 3D separated wake account for a truck like that at highway speed? The answer is about half of that. So the 3D separation creates a low pressure region in the wake of the vehicle, and that is, especially at higher speed, is a primary driver for fuel efficiency. And our research tries to look into the dynamics of the wake in figuring out how to better control them. The setup is an axisymmetric body like that. It is designed to be as aerodynamic as possible in the front part of the body, and it has massive separation at the back of the body. It creates 3D wakes at the back and has a good set of experimental results by George Rigas et al. Published in GFM. And looks like a bullet, but this is not a bullet. It's supposed to be a model of a car or a truck. And we used a direct numerical simulation to study this bluff body, and this is our domain. We used the incompressible Navier-Stokes solver called VIDA. It's a finite volume method with the unstructured capability, but it is best with a structured mesh and has a fourth order accuracy if the mesh is very structured, very nice. And we use a mesh, we use two meshes, one 5 million and 10 million cells. And this is what our mesh looks like. So now we study this problem in a range of Reynolds numbers. As you can expect, when you have very low Reynolds number, it starts with a completely axisymmetric flow. When the Reynolds number goes a little bit higher, one of the symmetry breaks. Although you still see a symmetric flow over there, but if you look at it sideways, it's no longer axisymmetric at that Reynolds number. Further up in Reynolds number, the flow stops being steady state and unsteady vortex shading starts to develop. And this is still very periodic, but as you go a little bit higher, Reynolds number 800, the vortex shading stops being periodic, and you can see this occasional burst of vortex happening that is not synchronized with the vortex shading. And as you go even higher Reynolds number, low dimensional chaos starts to develop in the flow field. And this is the range of Reynolds number we are going to look at in our 3D global linear stability analysis. And also for the higher Reynolds number cases, we perform the Lyapunov stability analysis as well as shadowing sensitivity analysis.